There we go. Hi, everyone. Happy Tuesday and welcome back. Welcome back to our ARM Tech Talk series. I'm thrilled you could join us today. This is the place for the latest and greatest trends, technologies, and best practices from ARM and our ecosystem partners, of which we're joined by one today, OpenSynergy, who are going to talk about how you can accelerate your automotive development cycle with their tools. And we're super excited today to be joined by them in today's ARM Tech Talk. But before I hand over to them, I'm going to go through a couple of housekeeping items. If you've attended one of these before, you know the drill. But let's get through those nice and quickly so you can hear from Mikhail and the team. So let's head to the next slide. Oh, thank you. Let's head to the next slide. So you can engage with us on social media. Use the hashtag ARM Tech Talks and on ARM as well. All 80 plus ARM Tech Talks are available on demand. Just head to youtube.com/ARM and you can click under the live tab as well as on the playlist tab. And there's a ARM Tech Talk playlist there. So do check out our playlist and please do subscribe and like this video and subscribe to our channel if you enjoy this kind of content. We'd love to hear from you. All of our upcoming tech talks are always available on arm.com/tech talks. That's the place to check them out and register so you don't miss any of them. So please make sure you do so to secure your spot. To give you a sneak peek at what's coming up next week, if we head to the next slide, we can see that there's a tech talk coming up from AWS, who are going to talk about their work with ARM on how they are embracing a cloud-to-vehicle continuum to enable software-defined vehicles. So that's going to be awesome. We've had a bit of an automotive theme for the last few talks, as you may have noticed. We've had Sensory, we've now got OpenSynergy, we've got AWS. We've got quite a few automotive partners that we've had over the past few talks, which is just awesome. We've had QNX as well last week, so I hope you managed to attend that one. If not, it's on YouTube, and do check that one out. That one was really great. But of course, you're here today to hear from OpenSynergy, and I'm thrilled today to be handing over to Mikhail. We're going to see a profile picture of him on the next slide. We're going to hear from him in just a second. Very quick introduction to him. On my side, he's the virtualization tech lead at OpenSynergy, senior staff software engineer. I'm thrilled today to be joined by him. Before I hand over, please do get your questions as usual in the Q&A box in the menu bar of the Zoom interface, and we'll get to those at the end. So, Mikhail, thank you so much for joining us for today's ARM Tech Talk. Please take it away. Tell us how you can accelerate your automotive development cycle with OpenSynergy.
Hello, everyone, and thank you for having me. I'll jump to the next slide right away. I'm staff software engineer in OpenSynergy, and I joined the company in 2017. Let me give a brief introduction to the company. It was founded in 2007, and already in 2010, it was producing the COQOS SDK, the first comprehensive virtualization solution for automotive specifically. And already in 2014, the first production level project came in truck telematics area. And in 2016, the COQOS SDK was using the Type 1 hypervisor for automotive edge ARM platforms. And later when I joined, hereafter, OpenSynergy developed an in-house solution, Type 1 hypervisor for ARM V8 platforms. Later, 2 years later, there are two big events happened. The first one is that the hypervisor was certified up to ASIL-B automotive level by ISO 26222 by TÜV. And another event is that there was a collaboration with Google to develop the so-called Android Route automotive platform, reference automotive platform, and OpenSynergy was honored to take part in this development. And I was part of the team as well. And together with Google, we developed a Android Route reference platform and COQOS Hypervisor SDK for this particular reference platform. It was launched a bit later. Then a big event for us that in a couple of years later, we added support for Qualcomm automotive platform generation 3. And on this platform, we had a project JoyNext, mass production project for an AVI system. And later today, we are happy to announce that we are having a COQOS Hypervisor that supports both ARM-A and ARM-R cores together. Right. And OpenSynergy has a vast ecosystem. We are working with silicon partners, we are working with ARM, working with automotive hardware partners, and also we're working with software partners such as Google, for example, and others. And we are members of the standardization bodies and platforms that provide us with an opportunity to develop open standards such as SOAFEE and OASIS. The reason why we do the SDK is because in the past, when we needed additional functions in the vehicle, we would develop a new piece of software, and we need a piece of hardware, and you just took all these hardware parts and try to put into vehicle. And nowadays, the amount of function is so great that it's a real big challenge for the automotive industry to pack this amount of hardware in a single car. And that is why we need virtualization, and we need to converge certain functions into one piece of hardware. And here comes the automotive VIRTIO platform by OpenSynergy based on COQOS Hypervisor SDK that is running on ARM platforms, ARM-V, specifically SoCs. The automotive VIRTIO platform consists of multiple parts. Of course, under the hood we have ARM SoC. On top of it, we have Type 1 hypervisor. And on top of the hypervisor and like in between, so to speak, we have different functionalities that provide the ecosystem for the virtual machines and devices to the virtual machines they need, such as power management and system management, trust zone mediation, so that every virtual machine can have access to the trust zone. And of course, we have VIRTIO devices that we develop that have access to the native device drivers and provide the virtual functions to the virtual machines, such as real-time virtual machines or classical ones like Linux or Android IDE-based systems. And to develop COQOS SDK, we have a product named COQOS Lab that is a solution that allows developers to develop and test software, and the hardware is actually located somewhere else. And this solution is also suitable for OEMs, for Tier 1 and Tier 2 companies. It is designed also for the SoC vendors to provide this hardware to developers. And also it is possible either to use COQOS Hypervisor license to develop in the lab, or it is possible to use your own virtualization solution to access the evaluation boards and to develop your software. Also, COQOS Lab can be potentially shipped and deployed at customer premises to collect the scattered ground boards that used for development. And today I'm gonna show you how do I use the lab on day-to-day basis, and how it looks in my development environment. I will connect to a lab, select a board, and will run my tests. And let's see. And as you can see in the picture in the middle, that's how more or less my working place looks like. So I have a thin client, like a PC or notebook, and I have visual. So I have visual stream from the boards, from the guests on the boards, and also have access to console and work basically remotely on my software remotely. And on the right picture, you can see how the COQOS Lab looks in reality nowadays. We have like a server rack with a bunch of boards in it, connected to different I/O, and you can control the boards remotely. But before jumping to the demo, I would like to explain what setup do I have. I have a setup with two virtual machines, two big virtual machines. I have a bunch of support virtual machines running there. Under the hood, I have an i.MX 8 board and two guests that I'm focused on. On the left side, on the picture, you can see a VIRTIO devices host that has access to the NXP hardware, so peripherals, I/O, and has COQOS VIRTIO devices that provide the virtual function to the guest on the right, such as what devices do we need? Engineer block device, random number generator device, GPU to show the display, others as well. And also, since I'm focusing on today on, let's say, IVI development, I would like to have access to video decoding using VIRTIO Video. Imagine I develop some video player application, and I would like to have access to VIRTIO camera or just camera device that is needed for me if I, for example, develop some application that has a camera stream from rear view camera or extended vision system. So I will be having these devices as well. And on the right side, on the picture, so the second guest, the Poki Linux, I have just a standard Yocto distribution built that runs kernel 6.1 with VIRTIO drivers enabled that are coming out of the box in the Linux kernel. Plus, I have the VIRTIO drivers that we are working on and will be running as modules. All right. Today on the demo, I will be using pre-build and pre-flash setup. So building Yocto takes some time, so I don't want to spend your time on that. And also flashing the board, sometimes it can take also quite some time, so I'll be skipping that part. I'll be connecting to Lab, COQOS Lab, remotely from my PC. I'll boot the board, and I will check that the screens to the board, the displays, can be accessed remotely using the browser, and it's up and running. Also, I will check that the console output from the guests is same, that the guests are up and running. And after that, I will run my video test suite and look at the screen and check the results, and also look at the test results in the consoles and the test usage automated. Also, if I will not have my test suite handy, I would like to run some tests from the console simply, and also check the displays with the camera test. Sorry. Right. So let's jump to the first part. I have already connected to the board, i.MX 8 board, and I have a console that has some tools to deal with the board, like reboot it, or fastboot flash the board, or enter fastboot, and so that. I'll be connecting with the board from a different console. Join the board. I have the same board console, so to speak, here. And yeah, let's see that ADB device is live, so I have ADB access to both VMs. I can push pull files or just use the shell there. All right, the board is live. Also, I can check the QR output from the board. This is conversion output from all of the guests. So every guest will put something into the console device, and the COQOS hypervisor will simply converge all together and put it out on the screen. If I would like to see output from a particular guest VM, I can just connect to the particular guest VM. So here I have i.MX 8 PSP. Sorry. So so we have kernel synth.1 here. And the second guest I'm interested is a so-called VIRTIO AR64 guest. That is a standard cookie distribution with VIRTIO drivers enabled. And it has kernel synth.1. Also, I have loaded here VIRTIO camera and VIRTIO video modules. All right, so let's run sorry, I forgot before running the test, I would like to check the board itself, the output from the board. And here I can see two displays, display number 1, display number 2. Both displays are being driven by the NXP guest. So it has access to the display controller, to the GPU device, and it shows Western desktop there. That looks pretty much standard. And the guest number 2, so the Pocky VIRTIO guest, is actually shown on the same Western display. So it's a client of Western that is running in the host VM. Yeah, so you can see that both boards are looking fine. And let's run our test. Okay, so it's running. What I did, I'm running a standard PyTest test suite. Selected some tests. I would like to test decoding of the using VIRTIO video, and I would like to decode some H.264 video, and yeah, so there is a test name. Then what it did, it actually checked that the board I'm connected to can handle this test, and it found that, okay, so I would like to use dual Linux use case and run test there. During the test, our test suite is rebooting the board. It skips the flash since you already flashed the board. It will check that the board is up and running. Yeah, so it's waiting actually for ADB devices to come up, since the tests utilize ADB a lot. It's much easier to do with ADB than with just regular consoles. Okay, so what's going on in the consoles? 0. Okay, so I can see that. Let's check guest 3. Right, it's I think it's a demo mode. It's putting. If for some reason the test suite detected that the board in some strange state that I had from the beginning, it will not execute the test. It will just reboot it, and until the point in time it's up and running, and it's ready to run the test. Okay, so the all tests are passed. So the board is up and running. So let's go to the display so we can see as well what's going on the display. And the test itself takes a video file, pushes it to the VIRTIO guests, and we're using a standard tooling, GStreamer. It will construct a pipeline, run the video, and check that there are no errors, there are no crashes, and such. Of course, it will take some time to push the battery, but it's up to the developer how to write the test. And eventually, I must get the video on the screen. I'm using the standard big bot bunny video that is used by GPU and video developers. And as you can see, the video is running, it is smooth, the colors are fine. Yeah, and no screen tearing. And then my test is also saying that it's good to go, 5 passed. So now I can create a pull request for my team to review it. And I have a proof that it's working. All right. And the second test I wanted to show today is camera test. Imagine I developed some camera application and I need access to a camera stream. For that, I have VIRTIO-based platform with VIRTIO camera in it. And in this particular scenario, the physical camera is not used, but we are using the so-called emulator of the camera stream, Vivid, from Video for Linux 2. And we are setting up this device on the BSP side, so where NXP BSP is running, and feeding the stream using VIRTIO camera to the VIRTIO guests for the applications to use it. All right, let me find the camera command. So what I'll be doing is I'll be using ADB as well. We'll connect to the second guest and execute a command. That is a standard GStreamer command that will use VIRTIO video. Sorry for that, it's VIRTIO video number 3. So we have video and camera device that also have /dev/video X name. So it's depending on the boot here in my setup. And then I would like to show this on the screen and see how it looks like. Oh, no, sorry, that's VIRTIO 4. All right. Oh, okay. So it's working. I have the video stream from the host side, from the PSP side, and I can check all the parameters of the video. I don't know, screen tearing, or if I would like to hook up a real camera and see the output, how it looks like in my application, or if I would like to simulate some events like, for example, the camera all of a sudden stopped responding and some noise, it's also possible. And the most important that I'm focused on my application in COQOS VIRTIO-based Linux, and what's going on the host side is not to my concern. So I have VIRTIO camera, VIRTIO video, and VIRTIO devices, and yeah, I'm good to go. And that's all I wanted to show in today's demo. Thank you for your time, and maybe you have some questions for me.
I'm sure people will. Thank you so much, Miguel. That's awesome. You know, it's great to see live demos in Tech Talks. I always love them. There's always a bit of a factor of, will it work live? But it worked pretty flawlessly. So it's really great to see. This is now your time to get your questions in to Miguel and the team at OpenSynergy. As ever, I've got a couple, but we'd love to hear from you what questions you have. So I'd like to kind of start with a question around the lab that you showed, the COQOS Lab that you showed. What are the requirements to access it? What are the requirements to access the COQOS Lab?
The requirements to access the COQOS Lab. So to access the COQOS Lab, you do not need to have hypervisor, OpenSynergy hypervisor license for that. And basically, every developer can access the lab, be it indie or company development.
Awesome. So people can just get in touch with you on that, which is great, and get in touch to find out more about that for sure. I'd love to talk about the ARM side of things, of course, as this is an ARM tech talk. What are the typical restrictions in cloud development versus using target hardware, right? And I'd love for you to talk about as well how the ARM architecture helps with that process.
Mm-hmm. Cloud or emulated environment, locally emulated environment, it's unlikely that it will be such a performant environment compared to the target ARM hardware.
Gotcha. And in terms of how does ARM architecture help you with that process? How does that commonality help you? Have you found?
Mm-hmm. ARM. For the when you use these open standards like SOAFEE or VIRTIO, this will accelerate your development because you're basically ARM helps to draw this common interface lines and then develop the parts you are interested in, your business is interested in, and give the rest to leave the rest somewhere else. And so by using, for example, SOAFEE architecture and VIRTIO baseline in the SOAFEE architecture, you can, just an example, there was a word binary compatibility. For that, you can just take a binary of the virtual machine with your function. That is, the only requirement is there to be ARM compatible. And you can run the same binary on different virtual platforms, be it cloud, be it edge, or be it just, maybe later on your PC.
Absolutely. And that's great to hear that kind of, and certainly we've heard that commonality of the ARM architecture from cloud to edge really helps with that process. And you touched on SOAFEE there. I'd love for you to, if there's anything more you want to add on how the SOAFEE initiative and the community of partners that we have in SOAFEE, how does that help that cloud native approach and helps us change that current development process? How does the SOAFEE community help there, would you say?
Mm-hmm. How the SOAFEE community helps there? The SOAFEE develops the open standard that provides you with like a guidelines and compatibility guidelines to develop some common ground that is extremely useful for the whole ecosystem and for the companies that participate. For example, in the SOAFEE, we had a discussion about the moving different devices from a virtual machine to a virtual machine. So if you are not using VIRTIO, for example, sometimes it's pretty complex thing to have pass-through device being moved from one virtual machine to another. For that, for example, you had a need to configure this virtual machine properly and all the dependencies on a particular platform. And the community came up with an idea. So SOAFEE community came up with an idea how to simplify this process, how to simplify the configuration management of the guests. And it was really, really enlightening as well for me how to fit it in the projects I have here around.
No, absolutely. I mean, with over 100 members in SOAFEE now, it's great to see that grow and also see the technical work that's going on with partners like yourself. So that's always really exciting. It's not just the numbers, but actually what's being delivered, which is just awesome. And you've touched on VIRTIO. I'd love to get your thoughts on VIRTIO and how VIRTIO fits into the COQOS Lab. If I use that VIRTIO to develop my own virtual environment, can I use that in COQOS Lab as well?
Yeah, so VIRTIO is a foundation for virtualization. In essence, it in virtualization sense, it provides you with an abstraction of this platform. And of course, you can use it for testing and development. And since you have this abstraction layer under the hood, you can easily move your functionality on top from one environment to another, like cloud and edge.
Awesome, awesome. Thank you. And how quickly, you know, for new EVBs, how quickly can OpenSynergy procure these new generation EVBs as well? Because I'm sure many people and customers on the call will be interested in hearing that.
We're working a lot with silicon vendors like NXP, and it is possible for silicon vendors to provide the boards for us, evaluation boards, and these boards can be accessed by both companies and indie developers, and these people can start developing the software right away.
Awesome, thank you. There's been a question around SOAFEE and NVIDIA. So NVIDIA is not yet a member of SOAFEE. However, if you want to reach out to the SOAFEE community on porting to ARM architecture and indeed want to reach out to ARM, then please do reach out to us. You can absolutely find us, connect with myself, with anyone from the ARM community and the SOAFEE community. We'd be happy to answer your questions and help port to ARM, the ARM architecture for sure. And NVIDIA are very close partners with us as well, so we can definitely help there. Question here about whose questions come in. Does your platform support interaction with software running on the Cortex-M4F cores in the i.MX 8M Quad-Max SoCs?
It's under development, the M cores and convergence of the communication between the application cores and the M cores is under development. Yeah.
Awesome. Thank you. No, thanks for that. And do keep any more last questions, the last opportunity to get your questions in before we wrap up. Does your platform support TI? I assume they mean Texas Instruments.
TI?
I assume so, unless it's something else.
Yeah. I believe yes. I believe we have a board.
That's great. No, that's good as well. It's always good to see what's what's supported out there for sure. And we love working with we really appreciate the partnership with OpenSynergy and you guys being an ARM partner. So before we wrap up, Mikhail, on your side, is there anything else you'd like to add and any final words you'd like to add to the audience today before we do take any last questions and wrap up?
Thank you for your time. Yeah, happy to be here. Yeah, thank you for having me.
No problem. And if people want to get in touch with you, just reach out to OpenSynergy. Any particular contact details you want? You happy for people to connect with you on LinkedIn, social media, etc.?
Yeah, you can just write to info@opensynergy.com or connect to me or anyone in OpenSynergy on LinkedIn. Yeah.
Brilliant stuff. Thank you. No, thank you, Mikhail, for an awesome presentation. So do get in touch with them if you've got questions about the supported hardware, opportunities for integration and opportunities for further discussion, then do connect with OpenSynergy. We'd love to hear how that goes on the basis of today's ARM Tech Talk. So Mikhail, thank you so much for a great presentation and a very heavy demo focused presentation, which we always love in these ARM Tech Talks. As I say, it's always exciting when you're doing something live. And it worked really, really well. Really exciting to see how you can use it to accelerate automotive development cycles in there. The recording and slides will be available from today's ARM Tech Talk very shortly afterwards. So do look out for those. And also do check out on arm.com/tech talks. Next week's ARM Tech Talk will be from AWS. So we're super excited to hear from them about our work with them on the future of mobility and the software-defined vehicle. So thank you so much again, Mikhail. Thank you, audience, for your great questions. And we look forward to seeing you again the same time next week, 4 p.m. UK, 8 a.m. Pacific. Thanks, everyone. Bye-bye.
Have a great day. Bye-bye.